Okay, now we're going to talk about how to find the domain of a composition of functions. Because now you have two functions involved, it is going to be slightly different than when you just have one function. When you have only one function, you go through the bullet points that we explained and you work through each of those. When you have two functions, you're going to have to go through the bullet points twice. You're going to have to go through the bullet points for the inside function. So you're going to have to find, first of all, the domain of the inside function or the inner function. It's sometimes called. The inner function is the one that is further to the right. And then the one to the left, we call it the outer function. So if your composition is F composed with G, then the inner function is G. Okay? So you're going to find the domain of the inner function by going through the bullet points. And then you're going to find this composition and you're going to simplify it. You're gonna actually do the calculation of doing the composition and simplifying it, and then you're going to find the domain of the result. So you're going to find that and you're going to simplify it, and then you're going to find the domain of the result. And then lastly, you're going to put both of those findings together. So you're going to want the set of all numbers that satisfy both conditions at the same time. In other words, you're going to find what is common to both. And that would be the domain of the composition. Okay, so we're going to do two examples, but each of those examples have two parts. Uh, so it's like four examples. All right, so suppose we have these two functions, f and g, where f is given by that formula, and then g is given by that formula. So we're going to find the domain of f composed with g, and we're going to find the domain of g composed with f. It's not going to be the same thing because the order matters. You have to find the domain of the inside function, and of course, if we change the order, the inside function is going to be different. So we could have a different result. Okay, so let's start with this one. Find the domain of f composed with g. Okay, so the first thing we're going to do is you find the domain of the inside function. So the domain of g, all right, and now look at what g is. G is just x plus 5. That's a polynomial, so that means the domain is from minus infinity to infinity. Polynomials always have that domain. I think we mentioned that in the previous video, in the previous page. But if you just go over the bullet points, then you'll realize there's no issue. The first bullet point, remember, is always if there's any denominators that have that have variables, the bottom cannot be 0. Well, there's no denominators here. And the second bullet point is if there's radicals of even index, well, there's no radicals of even index, so that doesn't apply. So that means there's no issue. All real numbers are good. So, but that's going to be, remember, this is going to be the case for every polynomial. They have domain from minus infinity to infinity, and that's a polynomial. Okay, so that one was easy. Now let's find f composed with g, find the formula for f composed with g, and then find the domain of that. Okay, so that would be like step 2. So now we're going to find what is f composed with g. Remember, that means that little circle becomes a parenthesis, so this is f evaluate at g of x. Now g of x is this thing. So we're going to replace g of x. We're going to replace g of x with x plus 5 because that's what it is. So this is f of x plus 5. Okay, now in the formula for f, I replace x with x plus 5. So in this formula on both sides, wherever I see x, I'm replacing with x plus 5. So this is going to be x plus 5, and then put here x plus 5. So this is going to be 2 over x plus 5 minus 8, which simplifies to 2 over x minus 3. So we have 2 over x minus 3 is the composition. And now we are supposed to find the domain of this. So we go through the bullet points. First bullet point, if there's fractions in the denominator, if there's fractions, the denominators cannot be 0. So that means we need to discard all the numbers that make the bottom 0. So we need the bottom to be not 0. So remember how you do that. You set it equal to 0. You solve it, which in this case means x equals 3. And then this is a number that you have to discard. You do not want that number because it makes the bottom 0. And then going over the second bullet point, there's no radicals of even index, so we're done. Okay, so we're done with that. So we found both domains. So that means the domain of the composition is just all numbers that are not 3. All real numbers different from 3. So now that we have both, we want to put everything together. So let's draw a line. So from the first part, we are allowed to use everything. But from the second part, we're not allowed to use 3. So that means 3 needs to be discarded. And what remains, everything that was not discarded, is our answer. So that means we want that, and we want this. So the domain is going to be the domain of f composed with g is going to be from minus infinity to 3 union from 3 to infinity. That's if you're using interval notation. If you're using set builder notation, this is just a set of all x's such that x is a real number. I'm not going to write that. And x is not 3. That was the only thing that we ended up with, the only restriction. X cannot be 3. That's it. So these two are the same answer expressed differently. Interval notation and set to builder notation. And that's it. That's all there is to that. You just have to find the domain twice. First of the inside function, and then you find the composition algebraically and simplify it, and then find the domain of that, then put both together. Okay, so let's do the next one. Find the domain of G composed with F. Okay, first step is find the domain of the inside function. So that means find the domain of F. F is the inside function now. The domain of F, well, that is F. Going through the bullet points, there's no radicals of even index, so that the second bullet point is not going to apply. Only the first bullet point applies. So all I want is all the numbers for which I want all the numbers that do not make the bottom 0. So what we need is x cannot be 8. Right? That's the only number that makes the bottom 0. That's the only number that we do not want. So that is the domain. So x cannot be 0. Now, let's figure out what is the composition here. So G composed with F evaluated at X. This is G of F of X, because the little circle becomes a parenthesis. And now F of X gets replaced with, what is F of X? F of X is that. So F of X gets replaced with 2 over X minus 8. All right. And now in the formula for G, in this formula, I'm replacing the X with this now. I don't have X inside the G anymore. I have this thing. So now, wherever I see X, I'm going to replace it with that. So that means this is going to be equal to 2 over X minus 8 plus 5. Okay, so that is the composition. And now we have to find the domain of this. The domain of this, well, you just go, I mean, first you simplify if you can. If you can, this one you don't really have to combine it into a single fraction. You may leave it like that. If you want to combine it into a single fraction, you can, but we can just go over the bullet points right now. Second bullet point does not apply because there's no radicals of even index. And the first bullet point is if there's denominators, the denominator is going to be 0. So this one again tells me that x cannot be 8 because that one makes that denominator 0. So really, from both sides, we got the same thing, that x cannot be 0. And now that is the only restriction that we found. Putting everything together, the conclusion is the domain of G composed with F is, now I'm going to do builder notation first, is a set of all x's such that x is not 0, 8. And in interval notation, well, you just imagine the line is broken up, instead of a 3 is now an 8. So it's going to be from minus infinity to 8, union from 8 to infinity. Okay. Okay. For the last example of this lesson, now you should try to do this on your own, see if you can figure it out. So I recommend that you stop the video and do it, attempt it, either both A and B or just at least one of them, B, let's say, for example. Okay, let's do this one. Find the domain of F composed with G first, where F equals this and G equals that. Okay, so first thing is you start by finding the domain of the inside function, the inner function. So the domain of G, which is the inner function in this situation, is what we need to begin with. All right, G, that's a polynomial. You see, that is a polynomial. So I don't even have to go through the bullet points because I know for polynomials, I'm going to end up with minus infinity to infinity because there's no issue. So the domain of this one is, without any effort, minus infinity to infinity. Now we find what this is. We figure out what that is and find the domain of that. Okay, so this is going to be, I'm replacing the g of x with g of x is what it is. The formula is right there. So I'm replacing uh, g of x with 4 minus 2x, 4 minus 2x, and then I replace in the formula for f, wherever I see x, I put 4 minus 2x. So that means this is going to be square root of, instead of x, I put 4 minus 2x plus 6. And then we're supposed to find the domain of this expression right here. There's nothing to simplify. I mean, there's nothing there to simplify. There's no like terms to be combined or anything like that. So let's find the domain of that. For finding the domain of that, you just go through the bullet points. First bullet point, if there's any fractions, denominator is going to be 0. Well, there's no fractions. Okay, so first bullet point does not apply. Second bullet point is if there's radicals of even index, then the inside has to be bigger than or equal than 0. Okay, this one here we have a radical of even index, so that means we need the inside, which is 4 minus 2x, to be bigger than or equal than 0. So you take whatever is inside the square root and you make it bigger than or equal than 0. And then you solve that. So let's solve it. Moving the 4 to the other side, let's move the 4. So it's going to be bigger than or equal than negative 4. And then you divide by negative 2. Remember that when you divide by negative 2, this flips. Do not forget that. So we're going to get that x is less than or equal than 2. Negative 4 divided by negative 2 is positive 2. Okay, so now we're done. I mean, for the first two steps. Now we have to put both of these things together. We need this. We need to put both together. The first part tells me the domain is everything. So that means you do a real line. You want from the first part only. That means you can use everything. The second part tells me I cannot use everything. I need to use only 2 and less. So this one tells me 2 allowed, so fill it in, and less. So the second part tells me I can use only this part. So that means this part cannot be used. Okay, that's not part of the domain. So we're ready for the final answer. The domain of f composed with g equals from minus infinity to 2, and then that's included, so bracket like that. That's in interval notation. In set builder notation, it's a set of all x's such that x is a real number, too long to write down, and x is less than or equal than 2. Alright, so that is it. Okay, let's do one last one. Let's find the domain of G composed with F. Again, you should really try it on your own, so maybe you should stop the video. Consider stopping the video and doing it. um, if not, then just keep watching, and then you can do it in the homework. Alright, first, find the domain of the inside function, which is now F. So first thing is find the domain of f, find the domain of f, the inside function. Okay, here's the formula for f. So going over the bullet points for that, first bullet point does not apply because there's no fractions of rational expressions. There's no denominators, so that does not apply. And then the second bullet point, if there's radicals of even index, then whatever is inside that radical, needs to be greater than or equal than 0. In this case, what is inside the radical is x, so that means that x needs to be greater than or equal than 0. So for the domain of this, I need x to be bigger than or equal than 0. Okay, so that is a domain expressed in in inequality notation. In the interval notation, which we don't really need, but it would be this uh, bracket 0 to infinity. Okay. All right. Now let's do the second one. Now we're gonna figure out what this is. G composed with f evaluated at x, which is nothing but g parentheses f of x. We're gonna simply figure out what that is, simplify it, and then find the domain of the resulting expression, the natural domain of the resulting expression. All right. F of x gets replaced with square root of x plus 6, because that's what the formula for f of x is. Right, here it is. That's what f of x is, square root of x plus 6. And now in the formula for g, you're going to replace any x's with this. So in the formula for g, which is just 4 minus 2x, the x is going to get replaced with our new expression here, which is square root of x plus 6. So that means this is going to be equal to 4 minus 2, and instead of x, you put square root of x plus 6. Which simplifying is 4 minus 2 square root of x minus 12, which is 4 minus 12, that's negative 8, which is uh, negative 8 minus 2 square root of x, or negative 2 square root of x minus 8, same thing. No, the 8 you cannot put it inside the square root. I mean negative 2 square root of x space minus 8. Okay, so that is the composition simplified. And now we find the domain of this thing. Going over the bullet points, the first one does not apply. There's no denominators. And the second bullet point tells me that if I have radicals of even index, which we do, then whatever is inside that square root, that root needs to be bigger than or equal than 0. So that means we need that x is bigger than or equal than 0. So this is duplicate. We already knew that x needed to be bigger than or equal than 0, so we got it again. So it's repeated. Okay, that's okay. And now we are done with the first two steps. Now we're going to put these two together. We can now give the answer. The answer is, in the real line, we can only use numbers that are bigger than or equal than 0. So this, that means I need that, all these ones. So the domain of G composed with F is going to be, in interval notation, is bracket 0 to infinity, and in set builder notation is a set of all x's such that x is bigger than or equal than 0. Right?